Right. Ladies and gentlemen, good evening. I'm Martin Rees, President of the Royal Society, and it's my great pleasure and privilege to welcome you here this evening. I welcome those in this hall, those in the overflow rooms, and those who are watching this event, which is being broadcast live on the web. And for all those reasons, a boring initial request, please turn off your mobile phones. The Michael Faraday Prize is now in its 21st year, and it's given by the Royal Society for someone distinguished in science communication. And the winner this year is Jim Al-Khalili. Jim is Professor of Physics at the University of Surrey, and he also holds the first Surrey Chair in the Public Engagement of Science. And in 2006, he was awarded an EPSA Senior Media Fellowship, which allowed him to pursue science communication in earnest alongside his other academic duties. And his academic field and his research interests are mainly in nuclear physics, on which he's written many papers. But he gives many public lectures in the UK and abroad, speaking to schools, scientific societies, and others. In fact, I'm told that he gave many lectures in 2005 all over the world, in the Czech Republic, Oman, and Thailand, and also in cafes and bars in Greece. That can't have been all that unpleasant. He's also a member of the Council of the British Association and the recorder of the physics section there. He's also an advisor to the British Council on Science and Technology. Well, Jim has a clear passion for bringing science to a wide audience, and he's written a number of popular books, and he appears regularly on TV and radio. His TV projects include Channel 4's Riddle of Einstein's Brain, and in the summer last year, a three-part series, Atom. It was shown then on BBC 4, but I'm glad to say it is now being reshown on BBC 2. So those without Freeview on our TVs can now watch it, but it's at 11:20 on Monday evenings. And you've missed the first two, but the third one, I think, is going to be next Monday. Jim is a fellow of the RAS and the Institute of Physics, and he received from them the Institute's Public Awareness of Physics Award. And it gives me great pleasure, therefore, to invite Jim to deliver the 21st Michael Faraday Lecture on the title, The House of Wisdom and the Legacy of the Arabs.
Thank you, Martin, for those kind words. Good evening, lords, ladies and gentlemen. A few years ago, a couple of years ago, in fact, I took part in a debate, a light-hearted debate here at the Royal Society on who was the greatest scientist of all time. And the two up for this great title were Isaac Newton and Albert Einstein. Now, as Martin mentioned, I had just made a program for Channel 4 championing Einstein. Well, in fact, it was Einstein's pickled brain that we were discussing in this program. But nevertheless, I was invited to put the case for Einstein. Now, I guess, like many scientists, I would argue that Isaac Newton was the greatest of all scientists. But I tried my best. I said that Einstein, where Newton had gone, Einstein had gone further. So Newton's mechanics were replaced by Einstein's special theory of relativity in 1905. Newton's law of gravity was replaced by Einstein's general theory of relativity in 1915. So, in a sense, Newton's ideas and theories were only approximate, and Einstein went further. Now, if that's the case, then we have to really think about the time that they worked in. No scientist works in isolation. They don't work in a vacuum. And you have to give credit based on what was known at the time. And for that reason, I think, Newton, of course, deserves the accolade. But of course, that would mean then that if we compare, say, Newton with Aristotle, who was the greatest scientist. After all, Aristotle was so much, back over 2,000 years ago, what was known then in science was so much less than what was known in Newton's time. Maybe Aristotle should be worthy of the greatest scientist of all time. Well, this evening, what I want to talk about, if I can open this bottle of water, is now, I should say from the outset that I'm not a historian of science, as Martin mentioned. I'm a physicist, so my expertise is in quantum mechanics and nuclear physics. So scholars in this field, certainly those in the audience, should forgive any naivety I might display. I won't be making any political points about Western attitudes for Islam. I'm interested in ideas and the history of those ideas, and to give credit where credit is due. Essentially to tell this largely untold story, not only in the West, but largely untold in the Islamic world as well, which is somehow more tragic. So why, apart from the obvious desire to put this record straight, does this subject mean anything to me personally? Well, I was born in Baghdad, and I spent my childhood there. And so I learnt at school about the many giants of Islamic science and Arabic science, but essentially as figures in history. I didn't learn about their actual contributions to science itself. So this is as much a personal journey for me as it is an academic one. So let me start from ancient history and go back to the time of Babylon. The ruins of the Hanging Gardens of Babylon, which I can show you my first slide of there. So there's me in the early 70s, I guess, with my younger sister, my grandmother, who was holidaying with us in Iraq at the time. The Hanging Gardens held no mystery to me, and we used to go there on school trips regularly. It was the day out. It was an hour's drive away. And you sort of take it for granted. And you take for granted the fact that if you are born and grew up in Iraq, that you live in a country that was the cradle of civilization, going back over 7,000 years. That was where writing was first discovered, and so the birth of history itself. I was well aware of this heritage and quite proud of it. But I think, looking at the troubles in Iraq today on the news, it's hard to credit that the heritage of those struggling to lead a semblance of normal life stretches back so long. But it's not the Babylonian history that I'm so interested in, but rather a time much more recently than that, essentially the period from about 100 years after the birth of Islam, and a period for several hundred years, so something between the 8th and the 11th century AD. For many in the West, this golden age of what was the Abbasid Empire, whose capital was Baghdad, is only really known through the romanticized tales of Arabian Nights, or 1001 Nights, Alf Layla wa Layla, as it should be correctly called. But these stories also hint at a period when art, literature, and most importantly, science flourished. Baghdad was then and would remain the center of world civilization for half a millennium. Many of the Arabian Nights tales are based on a time where the Caliph of Baghdad was Harun al-Rashid. He's this larger-than-life caliph who pops up in a number of stories with his vizier, and he ruled, in fact, he was a true character, he wasn't fictional, he ruled between the end of the 8th and the beginning of the 9th centuries AD. But when it comes to science, it's in fact Harun al-Rashid's son, Caliph al-Ma'mun, who is most interesting to me. This period, between the 8th and the 11th centuries AD, remember, was a time when Western Europe languished in the Dark Ages. And to a certain extent, in the West, that term, the Dark Ages, is projected onto the rest of the world as well. Well, it certainly wasn't the Dark Ages during the early years of Islam. So this is a story about the positive face of Islam, because it was a period when the spread of this new religion and the desire of the scholars to understand and interpret the Quran drove them to develop a worldview based on a mixture of theology and rational scientific thinking. And it produced wonderful advances in a range of fields, from astronomy, mathematics, to medicine, to physics and chemistry. Basically, almost every branch of science. I believe it's never been more timely or more resonant to explore the extent to which Western culture and scientific thought is indebted to the work of these Abbasid scientists. This was a period that saw the birth of the modern scientific method itself. It's a period that saw the birth of, the first real physicist, whom I'll say something about in a moment, Ibn al-Haytham, and in fact the first real chemist, Jabir ibn Hayyan. Let me say something about, in the title, it says Arab science. Of course, that is completely wrong. But what I want to make a case for is to call it Arabic science. Now, many would even disagree with that. They feel that this really should be called Islamic science. So let me say a few words about my motives for this name. By Arabic science, I don't mean the science that was practiced by people only of Arab blood. But by Arabic, I mean the science that we have as a recorded record that was written in the Arabic language. Of course, many of the great Abbasid scientists weren't Arabs. In fact, a large fraction of them were Persian. And so, quite clearly, Persians would feel somewhat insulted to refer to this period as Arab science, or Arabic science even. Many Muslims might feel strongly that this period should be called Islamic science. Indeed, it is, in the sense that the explosion of scientific creativity would not have been possible without the spread of Islam. And certainly the early Muslim thinkers were quite clear about their mission, because the Quran requires all Muslims to study what's called al-samawati wal-ard, the skies and the earth. Even the Prophet Muhammad tells his disciples to go out and seek knowledge wherever they may find it, even if they have to go as far as China. Of course, this knowledge, in Arabic is ilm, referred to all knowledge, primarily to theology. But of course, at that time, this new religion made no distinction between theology and science. It was, since what was written in the Quran was the way the world worked, you go and find out how the world works, and that will help you interpret the words in the Holy Book. But not all the scientific work was carried out by Muslims. So it would be unfair to entirely refer to it as Muslim or Islamic science. Certainly in the early days, there were many Christians and Jewish scholars who worked in Baghdad. The spread of Islam certainly created this atmosphere of scientific culture in a way that the spread of Christianity a few centuries before hadn't. Sure, there were the pockets of scholarship among the Nestorian Christian community in cities like Edessa and Antioch, but nothing like the scientific activity a few centuries later under Islam. So what unified Muslims, Christians and Jews, Arabs and Persians was the Arabic language. And Arabic was to remain the international language of science for about 700 years. As an indirect way of making my point, consider the work of the great Greek astronomer Ptolemy, who produced the book Almagest, which is one of the greatest books ever written. Ptolemy worked in Alexandria, so of course he was most likely an Egyptian. No one refers to Ptolemy as the Egyptian astronomer. He's referred to as a Greek astronomer. because Greek was the language of science at the time. And finally, as many people have already pointed out, there is no such thing as Islamic science or Muslim science, as it's often portrayed in the West, because science cannot be characterized by the religion of those who engage in it. One danger is the following. Nazi Germany in the 1930s tried to discredit Einstein's theory of relativity by referring to it as Jewish physics. I don't want to see the term Islamic science used by those who would wish to attack Islam to downplay its importance. There's no Jewish science, as there's no Christian science or Muslim science. There's just science. Of course, the period I wish to discuss was brought about by Islam, and that's a different matter, which no one really can argue with. So, back to the 8th century, and the political climate in Baghdad was dominated by a movement of Islamic rationalists who sought to combine faith and reason. They were known as the Mu'tazilites, or those who keep themselves apart. Their theological view on the nature of free will, which I don't want to get too deeply into, was at the time supported by the Caliphate in Baghdad, particularly Al-Ma'mun. And this led to a spirit of tolerance of the Abbasids towards other faiths, which saw these Christian and Jewish translators in particular coming to Baghdad and helping them translate many of the great Greek texts into Arabic. So this was a period when scientific inquiry was encouraged no matter what the scholar's religious background was. Strangely, though, that tolerance didn't extend to within Islam itself, because Al-Ma'mun carried out what essentially was an inquisition against all those who did not toe the Mu'tazilite party line. It wasn't quite as nasty as the Spanish Inquisition, but nevertheless it shows that tolerance seemed only to go so far. So the story, I guess, in the sense that it has to start at some certain time, I will begin it in the year 813. That's when Al-Ma'mun came to power after kicking his brother out of Baghdad and, I guess, having him beheaded, I think, which is not very nice. But at the time, it's said that Al-Ma'mun had a vivid and life-changing dream. He dreamt that the Greek philosopher Aristotle came to him and told him that he had to go out and seek knowledge and wisdom. So this was a starting point for Al-Ma'mun's lifelong obsession with science and philosophy. What he did was create a famous academy. Now, historians disagree on when this academy was actually formed, and many would argue that it existed before Al-Ma'mun's time. But before that, if it did exist at all, it was most likely just a translation house. But what he created was the House of Wisdom, Beit al-Hikmah. It was a translation house, it was a library, it was an academy in which he brought together many of the greatest scholars of his time. There are many famous works of art depicting life in the House of Wisdom, not just translations, but actually carrying out proper scientific research. Great names like the philosopher Al-Kindi and the mathematician Khwarizmi were recruited by Al-Ma'mun to this academy. It was what we would now call a university. This was a place where these academics were allowed, were sponsored, were provided money to live and to carry out their research. And the House of Wisdom quickly became the world hub for scientific intellectual activity, and attracted the greatest of Arab and Persian philosophers and scientists for several centuries. Al-Kindi, in particular, was a man so venerated, he's known simply as the philosopher of the Arabs. Unlike many other later philosophers who were Persians, Al-Kindi himself was an Arab. He was born in the town of Kufa, south of Baghdad, which is in fact the birthplace of my father, who's in the audience tonight, so sort of a nice resonance there. Al-Kindi was born some years before my father, I hasten to add. in 801 AD, and he was the first of the great Abbasid polymaths. Not only did he introduce the philosophy of Aristotle to the Muslim world, he also made it both accessible and acceptable to a Muslim audience. But even greater men were to follow Al-Kindi. And what I want to do is mention three in particular, who are the three that I mentioned at the start of the lecture, I believe deserve to be in my top 10 list of greatest ever scientists. The first is Ibn Sina, known in the West as by his Latinized name of Avicenna. He's without doubt one of the most famous scientists of all time, Muslim or non-Muslim, and he's known far and wide around the world. He's probably best known as the greatest physician of the Middle Ages. He was also undoubtedly the greatest philosopher of Islam, and one of the most important of all time. Just as the work of Aristotle can be regarded as the culmination and climax of ancient Greek philosophical thought, so Ibn Sina can be regarded, or his work stands as the pinnacle of medieval philosophy. Although, of course, it is worth mentioning that other great philosophers, such as Al-Khalili and Averroes, came after him, who also deserve, in some people's view, equal importance in terms of their contributions to philosophical and theological thought. Ibn Sina was a Persian. He was born in the city of Bukhara, which is now in Uzbekistan. He was a child prodigy, and he carried throughout his life this self-assured arrogance. He became a huge celebrity. Although supposedly a devout Muslim, he nevertheless enjoyed a somewhat hedonistic lifestyle. He never married, and it is said he enjoyed the company of women and more than the odd glass of wine. He burnt the candle at both ends, and in fact didn't live to old age because of his rather heavy lifestyle. His fame as a physician is primarily due to his book, The Canon of Medicine, which was the standard medical text both in the Islamic world and in Europe for over 600 years. Can you imagine a recommended textbook representing the whole of a discipline that was used for over 600 years? Even greater than his Canon of Medicine was his book, Kitab al-Shifa, which is commonly translated as the Book of Healing. But it's not a medical text. Shifa is probably better translated as cure. And what he meant by the title was that this was a book that was meant as a cure for the world's disease of ignorance. This was a book in 9 volumes, and it covered logic, arithmetic, geometry, astronomy, music, and of course, metaphysics. Despite this breadth, I don't regard Ibn Sina as a true polymath. He didn't have the encyclopedic mind, nor the breadth of impact across so many fields as a far less famous Persian who seems to have lived in his shadow, and yet who is, for me, the greatest all-round scholar of Islam. And his name was Abu Rayhan al-Biruni. That he ranks as one of the greatest scientists of all time makes it all the more puzzling why he's so little known in the West. Indeed, I'm unaware of a Latinized version of his name. You'd think that all those worth mentioning, the really true great scientists of Islam, would have had Latinized versions of the names, for heaven's sakes, and he doesn't seem to have one. Not only did he make significant breakthroughs as a philosopher, mathematician, and astronomer, he also left his mark as a theologian, encyclopedist, linguist, historian, geographer, pharmacist, and physician. He's even regarded as the world's first geologist and the world's first anthropologist, having written extensively about his travels over many years throughout India. I would regard him as the Leonardo da Vinci of the Islamic world. Al-Biruni was completely and single-mindedly devoted to his research. He never married, but he never sought power or wealth. It's said that after he dedicated his great work on astronomy and geometry, a book called Qanun al-Mas'udi, to the Sultan, he was rewarded with an elephant loaded with silver. But he couldn't accept the gift. He sent it back to the Sultan and said, "Thanks, but no thanks. I have no need for such wealth." What a nice guy. The third man, worthy of a place in my top 10 list, is an Arab. He's regarded not only as one of the greatest physicists of all time, but as the very first true physicist. And his name is Al-Hasan ibn al-Haytham. The Latin version is Al-Hazin. We're taught at school that Newton was the father of optics. School science books are full of Newton's famous experiments with lenses and prisms, talking about his study of the nature of light and its reflection and refraction, decomposition of light into the colors of the rainbow, and so on. In fact, it's Ibn al-Haytham who is the true father of optics. I don't want it to sound as though I'm over-egging this to try and diminish the importance of the Renaissance European scientists and say, well, no, of course, these Islamic scientists got there before them. But credit where credit is due. Ibn al-Haytham was the first person to correctly explain how vision works. The Greeks couldn't agree, and this sounds ridiculous to us, but the Greeks couldn't agree about how we see things. Is it that light bounces off an object into our eyes, or that our eyes emit light to shine on an object, allowing us to see it? Well, Ibn al-Haytham carried out experiments to prove that, of course, it's the light that bounces into our eyes, which is the way we see. He went on to describe reflection, refraction. He invented the pinhole camera. He carried out many, many experiments in optics. But more crucially, Ibn al-Haytham is regarded as the father of the modern scientific method. If you look up in most dictionaries, this is defined as the approach to investigating phenomena, acquiring new knowledge, or correcting and integrating previous knowledge based on the gathering of data through observation and measurement, followed by the formulation and testing of hypotheses to explain the data. It's often claimed, certainly in the West, that the modern scientific method wasn't established until the Renaissance by the likes of Francis Bacon and René Descartes. But there's no doubt that Ibn al-Haytham, along with, in fact, al-Biruni, arrived there much earlier. Ibn al-Haytham was a sort of colourful character. He was summoned to Cairo by the Fatimid Caliph there at the time to solve the problem of regulating the floods of the Nile. Ibn al-Haytham at the time was living in Basra in southern Iraq, and he claimed that he could figure this out by building canals and dams and irrigation techniques. When he got to Egypt, he realized this was completely impractical as an engineering problem. But so as not to incur the wrath of the caliph, this temperamental caliph, he pretended to be insane. Thought that'll get him out of it. Well, didn't quite get off scot-free. He was placed under house arrest and wasn't allowed out for 10 years, in fact, until the caliph died. He didn't waste that time, of course. He wrote many, many texts, including his famous book of optics. There's much more I'd like to tell you about the sheer breadth and achievements of the Abbasids, but I'd like to focus on a few highlights in a range of a few major disciplines. So let me begin with mathematics. It's well known that we in the West inherited our number system from the Arabic. It's also commonly heard that the Muslim world or the Arab world invented zero. But of course they didn't. The Indians invented the symbol for zero several centuries before the Abbasid period. And in fact, the numbering system originates from India. Well, what we call Arabic numerals are the numerals that we use. The numbers at the top are what Arabs use, and they're called Indian numerals. So there's a bit of a confusion in terms of names. But you can see in the box below that the symbols above the ones that you'd recognize, are the ones that would have been in use in the early Abbasid period. And you can see, actually, if you look, the 1 is 1, but if you see the 2 and 3 above, if you turn them 90 degrees anti-clockwise, you can see our modern Arabic numerals, the 2 and 3. What's interesting is the symbol for 0, the circle that we use was a circle then, but the Indian numerals used in the Arab world today now use a dot for 0. What do they use for a decimal point, you might ask? Well, they use a comma for a decimal point. So everything's fine, there's no confusion. I should just add, of course, that when we talk about a 0, there's a distinction between a symbol for 0, for nothing, and also some sort of way of using 0 as a placeholder. Now, even the ancient Babylonians needed in their civilization to make some distinction between 11 and 101. And there was indeed a way of doing that within their system of numbering. Now, if we move on from numbers, here's an exercise for you to work out. Suppose that a man in his illness emancipates 2 slaves, the price of one being 300 dirhams and that of the other 500 dirhams. The one for 300 dirhams dies, leaving a daughter, then the master dies, leaving a daughter likewise, and the slave leaves property to the amount of 400 dirhams, with how much must everyone ransom himself? This was one of the exercises from a book that is probably one of the most famous books ever written in mathematics. It's called Kitab al-Jabr wal-Muqabala, translated as the Compendium on Completion and Reduction, and is written by the great Persian mathematician in the House of Wisdom, Al-Khawarizmi. In fact, Al-Jabr, in the title, is where we derive the word algebra. Al-Khawarizmi, like Ibn Sina and Al-Biruni, was born in today's Uzbekistan. So I think I'd really like to visit that place that is the birthplace of so many of these great Persian scientists. However, contrary to popular myth, Al-Khawarizmi was not the father, or the inventor, I should say, of algebra. We can trace the rules of rudimentary manipulation of equations, of symbols within equations, back to the 3rd century AD and the Alexandrian mathematician Diophantus. But what Al-Khawarizmi did was unpack algebraic calculations and solutions by writing entirely in prose. So he would say, you take this number, take the square root of it, and then add 3 to it, and then divide the answer by 4, completely in prose. What he did was not only turn algebra into a proper subfield of mathematics, but he showed how it could be used. Because people, for instance, this example shows why it would have been useful for people to understand some of these rules of algebra in situations like inheritance and taxes and finance. So for that reason, we can say he was the father of the field of algebra, even though he wasn't the person who invented all the algebraic techniques of taking a symbol from one side of the equation to the other and remembering to change its sign, and so on. What's less known, maybe, in terms of the contribution of the Abbasids to mathematics, is that they helped create another subfield of mathematics, namely trigonometry. This was almost entirely developed by the Abbasid mathematicians, people like al-Battani, Abu al-Wafa, and al-Biruni. In fact, al-Biruni famously made the first determination of a really accurate determination of the circumference of the Earth using trigonometry. He essentially, using a technique that we call triangulation, measured the height of a mountain in India. And from that, he was able to determine the radius of the Earth and the circumference of the Earth to an accuracy of within a couple of 100 miles. In geometry, Ibn al-Haytham, his name is famous. It's known as, there's a problem that's famous known as Al-Hazin's problem, which is to do with finding the position on a circular mirror if light shines from one point and has to be bounced back and reflected into another point. Because if you don't find that point spot on, it's very hard. It's not like looking at angles of incidence and reflection on a plane mirror. On a spherical mirror, it's a difficult mathematical problem. Ibn al-Haytham was the first person to solve this mathematical problem geometrically. He used a technique called conical sections, whereby if you take a cone and take slices through it at different angles, you get different shapes: circles, ellipses, hyperbole, and so on. The technique of solving these difficult equations, known as quartic equations, is made much simpler using geometry. To find a correct algebraic problem to Al-Hazin's problem wasn't really found until the end of the 20th century, in fact. Astronomy is another field where the Abbasids made tremendous advances. We know that Ptolemy had written his great book, Al-Majest, that was translated into Arabic. But you look at popularized versions of astronomy, popular history, accounts of astronomy, and you would believe that nothing took place between Ptolemy and Copernicus in the 15th century. Now, of course, the reason for that is because those two landmark scientific theories are very important. Ptolemy believed that the sun revolved around the Earth. It was Copernicus who proved finally that, in fact, it was the Earth that revolved around the sun. But Copernicus relied on many Abbasid and other Islamic astronomers in his work, and even gives credit to many of them. Of course, the Abbasid astronomers didn't have telescopes, so they had to make use of star charts and tables of numbers. They used a device which they invented called a Tusi couple, whereby you have a smaller circle within a larger circle, and you take a point on the smaller circle, and you have the smaller circle go around the larger one, and that point sort of wobbles to and fro in a way that could be used to mimic the motion of stars and planets. They also developed very sophisticated astrolabes, which allowed them to use them for things like triangulation and to track the motion of heavenly bodies across the sky. Even in astronomy, Al-Biruni shouldn't be forgotten. He's regarded as the first scientist to figure out that the Milky Way galaxy, which you can see as long as the light pollution isn't too bad in the sky, he was the first scientist to figure out that the Milky Way was, in fact, many, many, many millions of stars, individual stars. This extract from one of Al-Biruni's books is actually not written in Arabic. This is written in Persian, in Farsi, where he shows the eclipse of the moon and the different stages of the eclipse. What's really amazing is that even though Copernicus was credited with quite rightly, with the discovery that the Earth revolves around the sun, the Abbasid scientists knew that the Earth was a sphere floating in space. In fact, Al-Biruni himself, who took this for granted, stated that astronomical data can be explained just as well by supposing that the Earth turns daily on its axis and revolves annually around the sun. So even though at the time it was believed that the sun orbited the Earth, he said, well, you could imagine it the other way around, and it wouldn't really make any difference. Okay, well, I guess I should speed up, see how much more I've got to do, and I do want to give time for questions. In physics, I mentioned the work of Ibn al-Haytham. There were many contributions in engineering, for instance, involving valves and pulleys and levers that required a quite advanced knowledge of mechanics. In chemistry, I mentioned at the start of the lecture that the first true chemist was from the Abbasid period. His name was Jabir ibn Hayyan. He lived even before the golden age of the House of Wisdom. He's regarded as the first true chemist, but in Europe, he's known as Jabir the alchemist. This confusion comes about because the Arabic word for chemistry is alchemia, and alchemia is what has been translated into alchemy. And so there's a confusion in the West that when they talk about the book of Alchemia of Jabir ibn Hayyan, that it's a book on alchemy. Now, sure, he did dabble in alchemy, but for heaven's sake, Newton dabbled in alchemy. But Jabir ibn Hayyan did also carry out many sophisticated experiments and techniques that are even used today in chemistry. What about medicine? Well, again, if we are asked who the first scientist was to explain, say, blood circulation, the stock answer is, of course, William Harvey. This is a mistake that has unfortunately not been rectified or challenged in the light of solid evidence uncovered in the 1920s in a Berlin library, which shows that the correct explanation of blood circulation, including pulmonary circulation, which concerns how oxygen is taken by the blood around the body and the role of the heart and lungs, should go to a 13th century physician called Ibn Nafis. There's a nice diagram from one of Ibn Nafis's manuscripts showing blood circulation and the digestive system. The two greatest physicians of Islam, certainly of the Abbasid period, were Ibn Sina, of course, and Al-Razi. Al-Razi lived in Baghdad in the 9th century, and he's regarded as being the father of gynecology, obstetrics, ophthalmic surgery. He even ran a psychiatric ward in a Baghdad hospital at a time when, in the Christian world, the mentally ill would have been regarded as being possessed by the devil. Inevitably, of course, Ibn Sina is regarded as the greatest of all physicians. Here's the picture of his canon of medicine, which brought together Greek, Persian, Indian medicine, mixed with knowledge, newfound knowledge by Ibn Sina himself. In biology, this is a fascinating topic, which is something that I've been looking into quite recently, because on the whole, the Abbasids weren't so interested in biology, in zoology, and botany. But a biologist of East African descent who was born in Basra in 781 was a guy called Al-Jahadh. Now, this literally means bulging-eyed. Jahadh al-Aynayn is the Arabic for it. He had these weird bulging eyes. The Caliph apparently called him, when he heard of his great reputation as a scholar, to Baghdad to tutor his children, and then changed his mind when the children were terrified by this guy's facial features. Well, here's a quote. Let me just read it out to you, then I'll unpack it a bit. This is from the Book of Animals. Animals engage in a struggle for existence, for resources, to avoid being eaten and to breed. Environmental factors influence organisms to develop new characteristics to ensure survival, thus transforming into new species. Animals that survive to breed can pass on their successful characteristics to offspring. Given the importance of Darwinian natural selection, and certainly the strong feelings that it provokes among many religious people, Muslims and Christians alike, it seems astounding to find something like this written in the 9th century, and has been largely ignored. Well, I got this quote from an Australian Muslim scholar who claims to have found it in the Book of Animals. It since turns out that he hadn't read the Book of Animals himself, so I took myself down to the British Library on Monday and spent a couple of hours using my rather rusty Arabic and a dictionary to wade through to find this quote. I was helped by an article by another Muslim scholar that can be found online, where he points to certain parts. This is a 7-volume text. Now, so this is the original Arabic. The version that I had in the library is a 100-year-old version, 1909, published in Cairo, and the 7 volumes are condensed into just 2. But nevertheless, I mean, given my shaky Arabic, it was a needle in a haystack. But it was helped by this article where he pointed to volume 4, page 23. And sure enough, while one doesn't find these words translated, there are sections in the text. It turns out the book is a mixture of theology, of folklore, and some pretty good zoology for the time. And he does talk about the environment affecting the characteristics of animals. It's not Darwinian evolution. It's not natural selection in the way we understand it today. And it's not meant to take credit away from Darwin himself, of course. Darwin is up there in the top 10 greatest ever scientists, and I'm not going to stand back from that. But to have a Muslim scholar used the words of the Quran as he interprets it to talk about the possibility that the environment can affect the nature and characteristics of some animals that can then, these traits passed on to future generations, is still remarkable. Okay, finally I want to move to engineering and just say a few words. There have been so many. I should make a plug for, there's an exhibition starting tomorrow in Croydon Watchtower, Town Hall in Croydon, called 1001 Inventions. I should have had a nice slide showing the book that's been published by the same name, showing all the wonderful engineering feats that have been carried out in the Islamic world. They range from mechanical machines and pumps and valves and clocks, and many grander projects such as water wheels and bridges and dams and irrigation canals were commonplace. But I just want to highlight one particular example, something known, it was called the elephant clock. This was invented by the greatest engineer of the Islamic world, a guy called Al-Khalili. His elephant clock is one of the engineering wonders of the ancient world. It's an object of artistic beauty as well as engineering brilliance. What you see on the right is a picture from the manuscript depicting the original elephant clock, which is about 2 meters high, I believe. A much larger than life replica has been built somewhere in the Emirates. Is that right? Thank you. Okay. The idea of this clock is that the elephant, the model elephant is hollow, and inside it is a bucket of water. Inside the bucket of water is a bowl with a hole in the bottom, and this bucket sinks slowly as water goes through the hole. As it sinks, it pulls a pulley, and the pulley pulls a serpent to tip it down, and the ball rolls down. It's a bit like sort of the Perils of Penelope Pitstop, if you remember those cartoons from the 70s, where certain things happen. Eventually, every half an hour, the chap on the front of the elephant bangs a drum. Incredibly accurate, and the cycle repeats itself. As he bangs the drum, then the bowl is lifted and the water's tipped out, and it starts all over again. Okay, finally, I want to come to just mention briefly something about why this golden age of science ended. A rather lazy and simplistic interpretation is to say that it all ended very abruptly in 1258 when the Mongols invaded Baghdad, ransacked the House of Wisdom. It said that the waters of the Euphrates and the Tigris ran black with the ink of the books that they threw in the river and destroyed. Well, Baghdad was, by this time, the mid-13th century, far from the only center of scholarship in the Islamic or Arabic-speaking world. Many great advances were already being made in other centers of excellence, such as Cairo and Cordoba. And we shouldn't forget, of course, that great names like Ibn Sina and al-Biruni never even set foot in Baghdad, as far as I'm aware. So the Mongol invasion of Baghdad shouldn't have been the cause of the decline of this period of science. Another argument is in the attitude of the Islamic world towards science, that by the end of the 11th century, the rationalist movement was coming to an end and being replaced by a more religious conservatism. But in fact, a lot of that discussion of religious conservatism versus rationalist movement was more of a theological discussion, and it shouldn't have affected whether people went out and studied scientific subjects. In fact, the sun was already setting on the Abbasid Empire before the sacking of Baghdad. A succession of weaker rulers came to power, and they simply weren't interested in sponsoring or supporting science and scholarship. The age of the House of Wisdom was certainly over before Baghdad was destroyed. In summary, it's always disappointing to see popular accounts of the development of science that seem to completely ignore this wonderfully rich period. I believe it's vital to acknowledge the debt owed by the world, European scholars in particular, to the Abbasid scientists of the Middle Ages. what a gaping hole there will be in our understanding of the history of science if we forget them. Thank you very much.
Thank you, Jim. We have time for just a few questions. If you want to ask a question, please put your hand up, and then when you ask the question, stand up and wait for the microphone. Who's going to start? There's one right at the back there.
Thank you. Professor, you were careful to explain to us at the outset how you were using the word Arabic and to distinguish it from Arab on the one hand and Muslim on the other. Is there anything you would see Islam itself as distinctively contributing to science?
Certainly. I mean, as I mentioned, the theology and science were completely intertwined in that period. And the motives for these scholars of carrying out scientific pursuits was entirely based on their religious belief. They wished to understand the world in order to help them understand and interpret the Quran. So in that sense, yes, Islam was completely behind the reason why they carried out their scientific research in the first place.
You haven't mentioned so far if any of these eminent scientists were from Al-Andalus, southern Spain, which my understanding is at this period was a significant intellectual centre.
That is true. It certainly was and carried on so long after Baghdad ceased to be a centre of scholarship. And in a sense, I've really focused my interests on that sort of 8th to 11th century. Now, you know, I mentioned people like Averroes. I haven't mentioned Ibn Khaldun, who was a great polymath, Tunisian, but I think he worked in Egypt and in Andalus. So, yes, there are many scholars that deserve a mention that I haven't done. I've deliberately taken a snapshot based around the House of Wisdom, because for me the House of Wisdom was what kick-started it in the first place.
We have one there, and then we'll have one there. Okay.
Thank you very much. Thank you, Jim. A fascinating talk. If I'm going to have two for the price of one, an observation and a question. The observation, I thought that the quote from the Book of Animals, to me, sounded a lot closer to Lamarckism than Darwinism. And one could argue that Lamarck is quite intuitive, and until quite recently the Russians believed it. So perhaps not quite as clever, not so insightful. But my question was about the circulation of the blood. From the diagram, it looked to me as if it only had one set of branches, as if the arteries and the capillaries. It didn't make it clear that there was an awareness that it then came back again by a different route. Is that in the text?
No, I think Ibn Nafis's contribution was to understand, in fact, that the heart had this partition that wouldn't allow one side, the blood of one side, to mix with the other. And so from that, he deduced there had to be a circulation. The blood couldn't go through. So in that sense, I would have guessed that there would have to have been some circulation, even if it wasn't clear from the diagram. The diagram, for instance, some of these things I need to check is whether this diagram was originally from the manuscript of Ibn Nafis or not is something that I need to make sure of.
Just a comment on the great scientists. I think you give too much credit to Aristotle. His science was terrible. His logic was wonderful. And my hero is Archimedes, who I regard as the first great scientist and the greatest scientist who ever lived, because he had no one's shoulders to stand on.
Did I mention Archimedes in my top 10? I didn't, damn. I think it was in my notes, but I should have done. But
yes.
I know people who would regard Aristotle as even greater than Newton. I don't agree with them, but these things, as with all top 10 lists, are subjective.
Question there, and then there. Yes.
You mentioned Al-Haytham's determination of the circumference of the Earth as
Biruni.
being...
Yes.
I think it was Al-Haytham, wasn't it, as being the first. But how does that knock Eratosthenes off his pedestal?
Well, it doesn't. There were many people who measured the circumference of the Earth, and I think many who got very close. You're right. My point is that Al-Biruni used trigonometry. He used the sine rule as well. Well, that's something I need to check. But my point was he made use of trigonometry such as the sine and cosine rule from the height of a mountain. And so he did it mathematically and measured it experimentally. Now, well, OK. In that case, then we have to give credit also to someone who came before. I will stand corrected if that's the case.
Two more questions, one at the back there.
Could you comment on the speculation that if the Arabic age of science had not ended but continued, then the sort of technological civilization that we enjoy today could have started 600 years before it did?
It's very difficult to say. I mean, I'm not a historian, but of course there are so many other factors that would have been important. The Ottomans ruled over the Muslim world for many hundreds of years, and they weren't such supporters of science as the Abbasids were. There are too many other factors to take into account to try and figure out what would have been had the Islamic Arabic science continued.
Just one more question. Very insistent gentleman here. Okay, yes, okay.
Thank you for this superb lecture. Why I was persistent is that I'd like to say a word in defense of Ibn Sina, because I've been trying to figure out a problem where he's been always depicted as almost like a playboy. But I think this comes in from his envious friends who have written against him. I have got evidence that some of his manuscripts he refers to when there is a problem, even in logic, which he is facing, he would go to the mosque and contemplate and stay there in so-called i'tikaf, meaning isolate and retreat, and hoping that God will sort of inspire him for a solution. I thought I really need to mention this because for some reason we tend to believe some rumors that he used to drink and he was sort of, but this man was apparently a religious man as well, which brings the point that I think that we have tried to mention, that Islam in those early years was sort of inspiring and instigating people towards science and knowledge. Thank you.
Thank you.
I think we could go on for a long time, but for reasons I'll explain in a moment, we need to clear the room fairly soon. But before we do that, I have to make the presentation. But before even that, I do notice that there are a number of former winners of this prize here. So many, could they put their hands up, all the people who've won this prize? So we have Lewis Wolpert, Ian Fells, Chris Zeman, David Attenborough, Richard Forty. And who else? And Walter Bodmer. There, yes. Oh, and Fran Bakewell. Okay, yes. Yes. But that's pretty good. That's 7 out of, I think, only 17 who are still alive. So that's a pretty good turn. Okay. Yeah, okay. Yeah. Yeah. Okay. Well, it's now my task to present this award formally, and it's in 3 parts. The first part is a scroll.
Do I open it?
No, I think so. Yes.
Just checking.
Yes. And the second part is a medal. And I thought there was a third part, which was a brown envelope. But I think that must be in the post. Okay. And with that, I'd like to ask you all to join me once again in thanking Jim for a lecture which has illuminated with great clarity and humour a greatly underappreciated era in the history of science. So thank you very much again, Jim.